start out our discussion of median by looking at two different situations. So in both situations, you have four people that have a different amount of money, and I've listed the mean of each situation above. So you could make the statement that the people described in situation 1 have a higher average amount of money than the people described in situation 2. However, if you're looking closely at the data, you can see that in situation 1, 3 people have $2 or less, and then just one person has $2,000. So that's artificially pulling the mean way up. Whereas in situation 2, the data is more tightly clustered around the mean of $497. So this is where mean doesn't quite accurately describe what's going on. So let's talk about an alternative. First, it's important to understand the concept of an outlier. In these two graphs, you have the data either tightly clustered on the left or along a trend line on the right, and then you have one data point in each situation that's way off and way different from the rest. In the table, staff members 1 through 8 all have a pretty similar salary, but staff members 9 and 10 make much, much more. So these outliers, like the $2,000 on the last slide, would artificially pull the mean either up or down and they're not giving an accurate representation of the data. So let's talk about median. So I have this list of numbers 1 through 5, and if I'm looking at just the center number there, that would be 3. So 3 represents the median. It is directly in the middle. There are 2 numbers to the left and 2 numbers to the right. If I have an even number of points in my data set, then I don't have a clear center. So I would be looking at 3 and 4 and finding the number that is directly in between, or in other words, finding the mean of those 2 numbers, which would be 3.5 or 3.5. Median is the center of the data set. So mean can also be considered a measure of central tendency, but median you can think of more as a physical center, the number that's directly in the middle. So let's look back at situation 1 from the first slide, and let's try to find a better way to describe the amount of money that these people have. If we took the median instead, that would be directly in between 1 and 2, or $1.50, and that more accurately represents the amount of money that most people in this situation have. Looking back at this table, if I'm taking the mean salary here, then that $90,000 and $95,000 will pull the mean way up and not give an accurate picture of how much the people at this business make. However, if I take the median, which would be directly in between 5 and 6, that would be $15,000, which is more accurate depiction of how much the usual or typical person makes at this business. Outliers affect mean. So if you have a data set that has an outlier like this one, 7, then mean will be greatly affected by it. So let's look at the difference. The mean with the outlier is 43.4, but the mean without the outlier is 52.5. Most of the numbers in this data set are closer to 52.5. The 7 is bringing the mean way down. Let's look at the same data set with and without the outlier. So if I just took the median with the outlier, my median would be 52. But if I remove that 7 completely, my median does not shift very much. It is 53. So outliers don't affect median as much, which means that if you have a data set that has an outlier, then you probably are going to want to use median to describe the center of the data rather than mean.